Yay, it worked. All right, so welcome everybody. We are recording. This is another monthly session of the Enterprise Agile Community and Meetup. That's been going on now for several years, and we've grown over the years, which is great. So now we have a lot of people that are participating. And then we record it and put it up in our cloud environment. Today we're very lucky because we have a gentleman, Allan Scherr, who's going to talk about how to harden software and our investments in our software, which is, I think, an important topic today. I mean, we're doing that in the company we're working at now and every startup I've ever worked at. So I think that's an important conversation to have. And he's like me, he's an ex-IBMer, but I think he was an IBM before me and left before me. But we're all, I always think we're all IBMers at heart. Anyone that's been at IBM for 20 plus years, you're an IBMer at heart to some extent. So I welcome him, and I'm so honored to have him here. He's got a rich background, very smart individual. And we're so lucky to have him here to share his knowledge about developing investment grade software, which is critical these days, I think. So Scherr, I will now turn it over to you.
Very good, thank you. So let me just say a little bit more about my background, because I think it adds a little bit, hopefully a little bit of credibility. This is a picture of me taken in 1964. I was a research associate at MIT doing my PhD thesis on the performance of time-sharing systems. Some of you may be old enough to know what a time-sharing system is, but basically, that was a teletype model 35. It did 10 characters a second maximum, and it was connected to a central computer along with 29 other workstations that were dialed in. And so it was, if you will, the first instance of a client server kind of configuration. One of the things I've noticed over the years is that if I look back over the last 50 years, the software industry has had 2 years of experience 25 times in many ways. So there's a lot of things that have happened over the last 50 years, a lot of problems that got solved, a lot of lessons that were learned, and I'm going to try to pull back to some of them. As an undergraduate, I studied logic design. I took a programming course in 1958 from Nat Rochester, who was a visiting professor from IBM, whose name is on the original patent for the stored program computer. The other instructor was John McCarthy, who's the guy that coined the term artificial intelligence. So I started off learning how to program, got interested in how the things worked. The next part of my career was, I'll just put it up. I worked on hardware software interfaces for the System 370. I led 3 very large operating system projects. I'll talk about one of them briefly in a moment. I managed all of IBM's networking products for a while. I was the director of the corporate staff overseeing the creation of the PC. I've got lots of stories to tell about how we got into the mess that IBM got into. And then I worked in applications. So I kind of worked my way up the layers. I was the CIO of the IBM Consulting Group when it was formed, and I was an IBM fellow. And then I left and went to work for EMC, where I ran a 250-person engineering group that basically did turnkey data backup and recovery. One of the things I accomplished in that job was the last 3 years I was in it, we met every quarterly goal every quarter for 3 years, which nobody in the job I was in had ever done before. The last point on here is kind of interesting. And I was at I did a consulting gig in about 2005 and the client handed me an Apple PowerBook, which was the old name for a MacBook, and said, "Here, try this. You'll like it. And if you like it, you can keep it, and I'll take the cost of it off your fee." Anyway, it was like taking a stone out of my shoe. So I've been an Apple user ever since. So I went from designing logic to being a user, and I've seen pretty much all of it. One of the assignments I had that's not on here is, for a couple of years, I managed IBM's, well, the IBM corporate usability group was in my domain. I ran the first release of a thing called MVS, stands for multiple virtual storage. The reason I bring it up is because it's probably the largest project I ever managed. It was released in 1974, so it's many years ago. It became the base for IBM's primary mainframe operating system. It was supposed to be the last release of that line of operating systems, and IBM was going to do a new line of computers, which never happened. So it became the base for the future. It's still being used today, much like the way Unix is. Give you a few statistics. There's 1,800,000 lines of new and changed code. NCSS is non-commentary source statements, written in a higher level language called PLS. The base in that project grew to 4.5 million lines of code, 20 groups in 12 locations worldwide, over 2,000 people at the peak, and it's 33 months from funding to general availability. And I'll use some statistics from that project as we go along. But I did 3 roughly that size in my career, all from start to finish, all successful. This is an interesting thing. When additional work was identified about 3 months after we started, we added the 20th group in the 12th location. Never thought twice about it, because in those days, IBM operated with integrity. I talked about the PC earlier. The PC guys in the 80s, you couldn't get 2 groups in the same building to work together. So what the PC guys did is they went outside to get software and chips, even though IBM had better software and better chips internally. MVS ran well on 3 megabytes of RAM. The goal was 2. I was criticized for going over. 1 megabyte of RAM in those days cost $500,000. We ran the extra time we used was in system test. The system test was 5,000 bugs were found, just to give you an idea of the scope of this thing. So I'm going to talk about why investment grade software is important, what it can do, how do you organize to do it, how do you design to do it, talk about usability as a user, one of my favorite topics, and then a little bit about project management and testing. So I like this. I'm using the term investment grade in the sense that people use it to talk about bonds and stocks. So investment grade bonds versus junk bonds, and not to cast aspersions on a lot of software, but quite a bit of it's quick and dirty. And I think from the point of view of what it could be, it's junk. When is it called for? There's a whole bunch of reasons why you would do this stuff. When you're transitioning from a startup to a successful major enterprise, obviously that puts a lot more stress on the software. When you're anticipating a long product life with a lot of releases, when release-to-release compatibility is needed, when function usability and reliability and performance are all important and need to get better with each release, and a large and growing customer base. The more customers you have, obviously, the more difficult, or the more difficult it might be to satisfy all of them. because they're not always the leading edge guys that are willing to put up with stuff at the beginning. And when development costs are important, and multiple groups in multiple locations. So this is not, this won't be present everywhere, but if some or most of these are there, then what I'm going to say will help. So one of the things to look at is the shifting priorities from a startup to a successful operation. So, you know, the customers at the beginning are leading edge customers. When it's successful, now you got to deal with the masses, or the unwashed, or the people that don't necessarily put up with issues in usability or reliability or performance. Time to market at the beginning is critical. It's less important after you're successful. New function, again, it's critical, less important later. Usability issues are tolerated versus being critical. Reliability the same way. Performance gets to be a problem when they have lots of users. Bug rates, they're high to begin with, and the more code you write, the more bugs you have. In fact, that's one of my mantras, is more code equals more bugs, always. And engineering costs at the beginning are, generally speaking, secondary, and they wind up being significant. This is a Dilbert cartoon, which I apologize for, but it makes the point I want to make, so I'm using it anyway. If you agree with the bosses, you can leave now. I'll let you look at the cartoon. Everybody got it? Okay. So let's talk about organizing development. I'm going to look at two cases. We're going to look at a single product with a user interface and a database, and then a suite of products that have requirements for data interchange and user interface consistency. Both cases have requirements, as it says here, for upward compatibility between releases, long product life, and enhancement over time. So Microsoft Office is a good example of the latter. Two ways to organize. You can organize development by feature, so have feature teams, or by software component. The organizing by feature, kind of like Agile, separate team assigned to make changes required to implement each new feature. Multiple features can be in development in parallel, and as well as fixing bugs from the field. Typical organization might be that you have a product manager that's got feature teams as the implementers, and hopefully cross-feature coordination, which in my experience, there's not a lot of evidence for in many products. And then the support guys presumably are the ones that manage the libraries and handle the testing and so forth. So let's do a simple example. So let's take a program that has two components, a front end and a back end. Front end interfaces with the users, the application data is in the back end. And you have a feature team that's going to make changes for one feature, and they're making changes everywhere. And another team doing changes for feature number 2 and making changes everywhere. And presumably the staff guy is coordinating these changes, although there's lots of evidence that that never happens. My favorite example, and I'll bring it up later, is I was signing up for an online account with the local power company. I put my telephone number in as all digits, and I got an error message that said it needed to be punctuated with dashes. So I fixed it, and then I went down to I added some more information, then it wanted my account number. And so I put the account, I had the statement in front of me, which had my account number that had dashes in it. So I put the account number in with dashes. I got an error message that said, no, we don't want dashes. it cleared the whole form and had to start over again. So my point is, either that software was written by one person who hated users, or it was probably written by two different teams, one that wrote the telephone number part of it, one that wrote the account number part of it, and they never talked to one another. Because they each had different ideas about how to do a user interface. And that's what often happens when you do this kind of stuff. So the issue is coordinating changes and so forth. That's pretty obvious. Cross-feature coordination would typically worry about keeping the integrity of the architecture of the product, the data model, and the user interface, and support, as I said earlier, would be testing and library management. Another way to go is to organize by component. So you basically give the front end to one group and the back end to another group, and you tell the front end group, your job is to keep the user interface consistent. And the back end group, your job is to keep the database changes consistent. And basically each group has specialists in each of these areas, rather than having everybody having to know everything. So the cross-component interface guy would worry about things like intercomponent interfaces and dependencies, which really is about how do you, and I'll get to this later, how do you test these things in an orderly way? And this chart kind of makes the distinction between the two. So if you have feature-based testing, you're testing by feature, you do regression testing, presumably to make sure everything still works that used to work. If you have components, the component people do their component testing. Code-based coordination in the feature-based approach is staff, as opposed to line in the component-based. User interface consistency is a staff function when you're feature-based, but the UI component owner is responsible for that in a component-based approach. Same thing with data model. And then finally, expertise required. Everybody, if you do feature-based, everybody presumably has to know about everything. And even though a lot of software engineers are confident enough to think they know everything, they really don't. Whereas it would be nice to have somebody that specializes in user interfaces, for instance, to work among the user interface component, and somebody that knows something about databases to work on the database part. So specialized knowledge is important, and it's something you need. Let's do the multi-suite case. Interproduct, if you have a suite of products like Word and PowerPoint, Excel, and so on, one of the requirements presumably is to have interface consistency between the products, data interchange, and so on. You can organize by product silos, which is basically what Microsoft did, or you can have components, and I'll show you the difference here. So on the left, we would build 3 products, each with its own graphic user interface. That's what GUI stands for. Logic, database, and middleware interfaces to the database. And then on the right side, the GUI guy, the end user interface guy, has a component that's shared by all 3 products. The database guy has a component that's shared by all 3 products, same with middleware. And the only thing that distinguishes the 3 products is the product logic is different. One might be a word processor, or one might be a spreadsheet. In the silo example, if you've ever used Word, PowerPoint, and Excel, which I'm sure you have, even though they have similar graphic user interfaces, they're serious incompatibility. They're similar but not identical, operationally similar, and objects don't move from one to the other very seamless. Never have and probably never will. And different file formats. There's a lot of evidence of unique code that could or should have been common. Again, back to my mantra, more code means more bugs. And I don't know about your experience, but mine is every time I use one of these products, I find a bug. The other thing that happens when you don't have consistent user interfaces, consistent database designs, is you wind up having to make conversion routines. So in the case of Word, let's say, and PowerPoint and Excel, there are conversion programs that take you from Word to Excel, Excel to Word, Word to PowerPoint, PowerPoint to Word, PowerPoint to Excel, Excel to PowerPoint. So there's 6 programs that got written because the databases weren't consistent. And those 6 programs have bugs, because every program has bugs, and I've seen those bugs. And they have, they cost money. So they affect the productivity of the development group. So if you have 3 products, there are 6 conversion routines, end products, which there are. I think the Office suite today has 5 or 6. Then there's n times n-1 conversion program. So five products in a suite would give you 20 conversion programs. Sorry. Yeah, 20. And again, more code means more bugs. I gave you the example of the power company's website. I had a knee replaced last year, and I've been doing physical therapy. So when you go into the physical therapy office, they have they send you an instant message to inform you of my appointments, and you just click on the instant message to confirm. Instant message just before the appointment has a URL to check in with, but you need a user ID and password to log on to their website to check in. But if you go to the kiosk when you get into the waiting room, they only need your last name and date of birth. Or you can just wave at the clerk, which is what I do. And then she uses yet another interface to put me in. It's crazy. Somebody ought to decide how they want to identify users, whether it's by user ID and password, or last name and date of birth, or what. I mean, it's obvious. Oh, there are other problems with it, which I won't get into. So you divide the component, and you divide the product into components. They correspond to missions or specialties or what have you. This is obviously the way IBM was organized back in the day. You have well-defined managed interfaces and dependencies, and no unilateral changes are allowed. I'll show you how to manage that in a moment. You can independently test the components if the dependencies are satisfied, and you can independently release components if the interfaces are maintained. The organizational model looks like this. On the left, you have the missions, and some kind of management of the missions. For instance, during the IBM's heyday, San Jose had databases, Raleigh had communications. The operating system was split between Poughkeepsie and Kingston, and so on. The measurement of these groups is quality, productivity, and product, and the satisfaction of the product managers. Product managers basically used these missions to provide code for the systems, and their measurement was revenue, profit, and customer satisfaction. The missions are cost centers, the products are profit centers. And, IBM worked this way for years. And it obviously is bigger than what you would need for a startup. But once you get to be very successful, this is what you would evolve to, in my opinion. One of the problems is there are a lot of players involved. Sorry for the speed of this. So if you have a bunch of people working on a product, everybody talks to everybody else normally. So you have n people, there's n times n minus 1 over 2. So if there are 8 people working on, or 8 groups, there's 28 conversations. If there's 10 groups, it's 45 conversations. So it grows exponentially. The way to organize is everybody talks to a central group. And now instead of n times n squared minus n over 2, what you have is n. So you have, for eight groups, you have 20, instead of 28 conversations, you only have 8. And the central group becomes the repository for commitments made, for schedules. They're the ones that coordinate the testing at the system level. They're the ones that negotiate inter-component interface changes and so on. They also, so they register all agreements. Side agreements are not enforced or encouraged, and it only works when there's integrity in the operation, which, by the way, disappeared in IBM in the 80s. I worked on a project which ultimately became AS400, but it was AS400 replaced 2 lines of mini computers in IBM. It was supposed to replace 6 lines, and it didn't get there because you couldn't get 2 groups to work together. The AS400 groups, the System 38 and System 36, which became AS400, were in the same building at least. And then when the PC came along, you couldn't get the PC guys to use anything inside of IBM because their point of view was you couldn't depend on any other group inside of IBM. Again, I got way more to say about that, but I'm going to leave it at that. So how do you design software to optimize, build, and test? You design it to be manufacturable. Design the system so it can be built and tested in controlled stages. This can work for applications, systems, whatever. You should not have to have all the pieces work before anything works. And the key to being able to do that is managing the dependency pattern. So the one on the left is everything uses everything else. And so you got to get it all running to get anything running. The one on the right, at least if you manage those, the yellow lines depict dependencies, the idea being you can get component number 1 operating without anything else. Then you get component 2 and 3 running, and then you can get 4, 5, and 6 running, and then 7, 8, and 9. That's the idea. So there's an orderly way to build and test this thing. By the way, when the mainframe software in IBM never accomplished this. It was always everything had to run before anything ran. But we did do this on later systems. So it is possible. It's even possible if you're in a object-oriented environment. I ran a project once where the object-oriented guys, or the faction of the development team that wanted to do it object-oriented, said it was impossible to manage dependencies like that. And they figured out a way to do it. So there's a lot of slides here. I'm not going to use all of these, but The idea is, how do you manage costs and schedules in an engineering project? I got a couple of funny slides. You know, I did it on 2 different stints in IBM. I audited projects. I ran the staff in a business unit in one case, and in a division, and at the corporate level. So I had 3 different jobs at different times to audit projects. And so one of the things you encounter is people are really pretty fuzzy about what they're doing. You know, we're working on something, we're headed in that direction, but we're not quite sure what the goal is. Another kind of group I audited was the process guys. We're doing it, you know, we're following this project, this process. And when we get there, you know, we'll know it. But it was all about, you know, if they had a schedule problem, the problem was, well, we're following the process. And then the yellow, this one's supposed to be a voyage of discovery. I apologize for these slides. It's not quite on the point here. One of the biggest problems I faced as a project manager is what I call function creep. For some reason, programmers like the program. Adding what I think of as gratuitous function has been a serious and chronic problem in a lot of projects. Function creep hardly ever makes any difference to customers and end users. And in my experience, often when a customer is asking for something, the words may have been put in his or her mouth by a salesperson or a programmer. It's not something they understand or want to use. I've had many meetings that had that conclusion. Function creep, the antidote is there's no such thing as a free lunch. Additional function is not free. I don't care if the programmer did it, you know, on the weekends. Project plans should be based on cost estimates for each component and function, and cost estimates ought to be re-verified at every phase during the development, and increases should be treated as breakdowns and handled immediately. And at least at IBM and in the projects I managed at EMC, we had people estimate lines of code for each function and for each project, and lines of code equals dollars because we had productivity numbers that we kept. And so if somebody raised their lines of code, the question is, what's the impact on the cost? And there always was one. And so we said, okay, you just increased the cost 10%, cut it back 10%. So people, they would take code out. And it was never a problem. And that's how we made the schedules, by the way. And then finally, the rigorous change process ought to be in place so that whenever a change is made to a user interface, to a functional requirement, to a intercomponent interface during the project, there's a change process, an engineering change process, much like what you'd see in a hardware engineering group. We put together a change control group early on in my career, and I had this in every project I ever managed, which is a committee representing each of the development groups. Every change had to be accepted unanimously by everybody, so no railroading ever happened. And it worked, even though it sounds like it wouldn't work. Certainly not if there's parties involved, like Republicans and Democrats. Success equals the committed function, high reliability, usability, performance, getting done on time within budget. Predictability requires well-defined goals, well-defined processes, well-understood history, and early identification and effective handling of breakdown. No programming project ever finishes without having some unforeseen problem crop up, and usually a lot of them. So you have to get good at identifying and handling them. Let me show you how to, at least one way to do that. So a breakdown, in my definition, is when it appears that current circumstances won't allow what you've committed to be done on time or within budget. Say it again. So earliest possible detection gives the greatest possibility for effective action. And the widest possible communication gives you the best range of possible solutions. I could give you examples of this, but the one I always tell is about the Apollo project had a fuel problem, and everybody knew about it, and it was a contamination problem, and the problem was found by there was a leak discovered by a janitor because he knew there was a problem, and so he was looking to, like everybody else, was looking for the source of the problem. Anyway. So the idea is to widely communicate that there's a breakdown so people can look. And keep data, is what the last bullet says. When there's no visible plan, you have this kind of thing going on. I vividly remember early in my career managing a piece of a project, and I was late, and somebody else was even later, and I was relieved. Not something you want to encourage. So people need to know they're building a cathedral, not just laying bricks. This repeats what I said. Okay, so I'm going to show you a chart that I used to create when I audited projects. And so look like this. So actual time versus planned time. So if you look at the chart, what was written there is I show up at the site of the project mid-January, and they tell me their plan. The plan is that checkpoint 1 will be done mid-March, checkpoint 2 mid-June, checkpoint 3 mid-September, and it'll be done in mid-November. So that's the plan. So I call them up in mid-February and I say, how you doing? Oh, we're still on schedule. So I draw the lines that way. And then I come back in April. How you doing? Well, did you do checkpoint 1? No, it's slipping day for day. How about checkpoint 2? Well, we moved that out a month. How about 3? That's still the same, and so is the completion date. You start to see an issue here. So then I call them in May 1st, they put a new plan together. So there's the new plan. And then I call them up, how you doing? Oh, we're still on schedule. I would go back to some of these places to look at their plans, and they would play dumb like there wasn't I hadn't been there before. So, and then, so I call them in July, how'd you do? Well, we finished checkpoint 1 in June, and checkpoint 2 is still on schedule, and so on. And we added another checkpoint. The idea behind this chart is you can see doom coming easily with it. Whoever, this is not a real project, obviously, I made it up, but this is not atypical of anything. So you always ought to know what the predictable outcome will be given your current course and speed. Beginner's mind rarely gets the job done. In other words, people that don't have any experience will commit to almost anything. The problem with them is they don't know when they're in trouble. And you got to know when you're in trouble. Unseen breakdowns or troubles can't be resolved. And in my opinion, in my experience, the most frequent cause of unsolvable breakdowns is they weren't discovered early enough. It's my favorite Chinese proverb, which I wish some of our political friends would know. Anyway, let me talk about usability, my favorite topic. In my opinion, it's the most neglected area of software development. Developers, from the point of view of a user, they don't seem to care about whether their software is usable. And we put up with an incredible amount of junk, and software engineers, and again, back to my experience, software engineers don't think like typical users, and they don't know it. Or they think, or if they're really cynical, they think users don't think the way they do, but they ought to. Software engineers don't have a lot of empathy for people, but I won't get into that. So I already did this example. Another user, entering city, state, and zip code. The three don't match, and you go into a loop. Why not put the zip code in first? But by the way, in New York State, the post office, the town you live in are two different entities. So I live in Hyde Park. I used to live in Hyde Park, New York, but the zip code was in Statsburg, and so if I put Hyde Park, New York as the town and the zip code, it would be an error. I don't know. So the point is, very few programs put the zip code first in the sequence. Anyway, on the iPhone, asking for a number and putting up an alpha keyboard. iPad at the doctor's office says press home to start on an iPad. I've been using iPads for 10 years or more, and I'd stop me. I said, what the hell's home? It's the button on some of the iPads. And then touch screen to start, which is jargon. So I'm a senior citizen, so I see people checking into doctor's offices a lot. And they stand there and look at these screens. It says touch screen to start. What the hell they ask me? What screen? Anyway. So let me talk about how to manage usability. You can't manage what you don't measure. Usability can be measured. One way to do it is to define tasks and measure how long it takes users to do them and how many errors they make along the way and how long it takes them to reach a steady state. In other words, learning. So if you look at task time and error rates, presumably they level off, and that's the learning time. What IBM did back in the day was that we had usability labs where people would do predefined tasks. They were typical users, and we'd measure all this stuff, with a video camera and people with stopwatches. However, it's not that hard to imagine instrumenting applications to measure the same stuff. How many times do people enter the application? How many times do they leave? Here's a kind of a graphical depiction. The width of this thing is the number of entries. How many times did they exit? How many errors were made, and so on? How many went from entering field 1 to entering field 2, and so on? That way, you can at least tell if you make a change, whether you've actually made an improvement. One of the least well-used sources of usability feedback, in my experience, is the help centers that people call. When somebody calls up, to get help, and typically in most companies that I've worked with, somebody will fill out a one-page form summarizing what the call was about. And they'll have what's called a closing code. At least IBM called them that, or a resolution code. And sometimes one of the codes often is, well, the user made an error. Or RTM stands for read the manual, although some people used to write RTFM to read the effing manual. A lot of the software we use don't have manuals, or works as designed. The user didn't like the way it worked. The point is, it's a valuable source of feedback about the usability of your product. And a lot of that information just sits on the shelf. Again, the evidence I have for it is when I was at IBM, nobody ever gave me a presentation about any of this stuff. And when I was doing consulting, one of the things I always asked for is to look at these things. And you could tell after I spent a few hours summarizing what was in all these reports, that the management of the company I was working with had never heard any of this stuff before. And yet, it's a source of customer dissatisfaction, and it's a source of where the squeaky wheels are in your software. In the last few years I was at EMC, I instituted the second bullet on here. Every time a user calls with a problem, it should be considered a usability bug and fixed. Obviously, it's sometimes not possible, but I didn't let people close problems as user errors, unless it was impossible to satisfy. And we wound up improving the usability of the product and having, I don't know if you're aware of it, but EMC had much higher customer satisfaction numbers than IBM ever even dreamed of having. And it was because of things like that. Some other things. Anytime a user enters something, it ought to result in some action. If there's no logical action, you should ask the user, what would you like us to do? And then my other favorite is when the user interface is improved, the old way of doing things ought to be preserved at least, and still at top until it stops being used. And the way you tell it stops being used is you look at the usability statistics. Here's my an example of Apple's inconsistent user interface. So on a MacBook Pro, there's a key on the thing that says delete. So you hit the delete key for a mail message, and it'll delete the mail message, but it's not documented to do so. There's a pull down on the edit, and if you do command delete, which is what that squiggly thing on the right side is, it'll also delete. In the Messages app, the delete key delete a message. It's also on the pull down for edit, and if you select a conversation, the delete key doesn't do anything, but there's a file pull down that does delete conversation. And photos, the delete key deletes photos. There's no pull down. On Finder, the delete key does nothing. And there's a pull down on the file to delete, on file pull down. But command delete works, or you could drag stuff to the trash, which doesn't work on any of the other Apple applications. Safari, which is Apple's browser, the delete key will delete whatever you've highlighted, and there's a pull down on file, same with calendar. So the point is that you would expect the delete key to do something, and yet there's a lot of places where it doesn't, and it's inconsistent, and it shouldn't be. I designed a user interface for typewriter-based command system back in the 60s, and I worked with a human factors guy named John McKeon, and he talked about the principle of least astonishment. The result of any user input should be what the user most expects and is the least surprising. And again, I don't think people look at stuff that way. Here's another Dilbert cartoon. The Dilbert saying user requirements include 400 features. Do you realize no human could ever use a product with that level of complexity? And the marketing guy says, good point. Let's add easy to use to the list. So I saw this cartoon years ago, and I spent a couple hours with Word just to see how many functions Word has. 550. If you look at the pull down menus, there's over 350 options. And on the ribbons inside of Word, there's another 200. There were functions, I've been using Word ever since it came out, and there were functions I had no idea what they did. I mean, so not only is there code there that produces bugs, but whatever. My daughter, my youngest daughter is a software engineer. She gave me a poster that says this. I'll close with the idea that a lot of user interfaces, like the Word interface, is just a bunch of tools. And what you really want is to be task oriented. What you really want is to say, okay, guy, I open my file so I can edit it. Or, you know, spell check the file or whatever, as opposed to trying to search for the command. There's a spectrum here, obviously, and one of the examples I use is the difference between an automatic transmission and a manual transmission in a car. I mean, the automatic transmission is not 100% task oriented, but it's more task oriented than a manual transmission. Manual transmission takes skill, just like a tool does. Automatic transmission takes less skill, just like a task-oriented interface would. Manual transmission is more fun. Back in the day, when I told you about the IBM usability group, they did a study back when Windows was just starting up, and they tested different versions of a point and click, drag and drop type interface with, that was mouse oriented against a structured menu approach. And what they discovered was that the structured menu approach had shorter task times, lower error rates, and lower learning times. So it was better than the drag and drop graphical interfaces that wound up being implemented in Windows and so on. Except the users didn't like it. The users they recruited to be in these studies were enamored with the fun of the point and click, drag and drop kind of interface, graphical interface. Except I'm not so sure. I could go on. I'm not going to go on. We'll get to the end of this. Okay, let's talk about testing real quick. Bottom line is, if it hasn't been tested, it won't work. It's a corollary of Murphy's Law. Components are, the way I would do it, components are tested by the component owners, shipped to the central group. The central group puts together partial systems or partial apps so that the dependencies of the other components are met so they can do their testing. And then finally, when it all comes together, they do a system test or a product test. And it's made up of functional performance and load testing. Functional tests typically ought to be written by somebody looking at the specs for the product, how it's supposed to work, and working from those specs to a test that uses the functions through the user interface. They should look at all the variations so they get coverage, performance testing, and then load testing to test for mean time to failure under load, using the functional test cases typically. One of the issues that I always used to get into was that the system test guys and the developers, the coders, were like head to head a lot. And so I finally came up with a way to separate them, which is I got the code owners to commit how many of their new test cases for the new function would run correctly the first time. Typical number would be 90%. And then how many regressions would they introduce? In other words, how many of the old test cases from the last release would run without an error? And typically I'd get them to commit to 99%. And then fixes for bugs that were found, you got 2 days. Or they would commit to 2 days. So, and then the test group commits to run some number of test cases every day. And that's their only job, is to run test cases and to ship diagnostic information back to the developers when the test case failed. So now you got a process that you can predict how long it's going to take. So you the bottom left, you have a bunch of test cases that haven't been run, and you start running them. You start with the new ones, and then the ones that run with error, you wait for fix. When the fix is available, the test case goes back into the bucket on the bottom left. When the test case is successful, now you can run them again as part of a regression test. So, and if you put the percentages in, looks like that. And what you wind up with is you should give the highest priority to unexposed test cases that have never been run or have failed. And now you can measure X, Y, and D to get the fixed process predictable as early as possible. And then you run the successful test cases for regression. So here's an example. So assume you have 1,000 test cases from a prior release, 200 test cases for new function. Use the numbers I gave you before. Capacity is to run 25 test cases a day. How long will the system test take? By the way, when we invented this approach, the test group that I took over had the test case library, and their exit criteria for the successful completion of a test was that they run every test case 3 times. You know, it made no sense at all. So here's kind of what it would look like. On the first day, you run 25 out of the 200 new ones. You find 2.5 errors and so on. So it's easy to compute. Here's what it looks like graphically. This is what, if you have 1,200 test cases, this is how long it would take. If you have X equals 90 and Y 99, it takes what, 42 days. And that's how long the system test should take. And this has worked. This is not a pipe dream. The other one which I found useful is to figure out how many bugs are left, or how many bugs are causing crashes. Suppose you observe that removing 1,000 bugs when you're doing reliability testing, you went from 4 days between finding a bug and it went to 5 days. And you found 1,000 bugs that made that change happen, and you just do the math. Turns out there's 1,000 bugs left. Back in the 70s, management wanted to have the operating system fail once a year. And where we got to pretty much was failed once every 5 days. You assume that the failures are caused by 1,000 bugs. By the way, the numbers on the last chart were real. If you assume that the failures are caused by 1,000 bugs, each bug has a mean time to failure on the average of 5,000 days, and assume the goal is 365 days, then to reach that goal, you have to reduce the number of bugs to 14. Assume 0 time to fix the bugs, and every fix is perfect. And anyone want to guess how long it takes to get to that point? Okay. 457 years of testing. First bug takes 5 days to find, the last bug takes just under a year. By the way, when the telephone system was introduced in the United States, the critical switching systems were designed to a mean time to failure of 40 years. When I got my PhD, I interviewed with Bell Labs, which was the R&D arm of AT&T back then. And they were showing me around their new electronic switching system, and the guy was giving me all the speeds and feeds. And he says, oh, and the mean time to failure for the switching system is 40 years. So how can you do that? And he said, we've been doing it for years. And they did. And then I worked at IBM on the FAA air traffic control system that was built on Model 50s of the 360 line. And that system hit a 15-year mean time to failure in use. And the president of the division wrote us all a letter and said we over-engineered it because the requirement was only to do it, only have a mean time to failure of 10 years. So we know how to do all this stuff. The problem is the will to do it. Okay. Okay, that was in the 1920s they got that. So what we did is we put in basically software error recovery. I'm not going to go through what all that's all about, but the idea is whenever there's a failure, you have the cause of the failure and you have the idea that the software should have recovered. So there's 2 bugs. And you can tell, you don't have to wait a week to get to the next bug. You can start injecting errors and seeing if the software recovers, which is what we did. So we could have as many, in those days we had big dumps, that would take core dumps. You could get as many dumps as you wanted, as often as you wanted, by just injecting zeros here and there in storage. Let's see. I'm not going to go through this. So the last point is don't allow the backlog of unfixed bugs to grow. Don't close bug reports. Consider the usability problems. You can read all this. Fix every known bug. When I first went to EMC, I was asked to talk to the guy running the product development group of the most successful product in the company. And I asked him, how many bugs do you have in your backlog? And he said, 5,000. I said, how can you do development on a pace that you have 5,000 known bugs? And he basically said, it's just IBM thinking. So it's like doing surgery in a pigsty, in my opinion. Beta testing is bogus. I don't know if you guys do that or think of it. IBM invented the term. In fact, I used to work for the guy that invented the term, Marty Belsky. And IBM using field testing to find software bugs was proven to be the most unpredictable, expensive way to find bugs that there is. Because the users weren't typical, the functional coverage that they did was not known, and the cost of bug found and fix was excessive. Okay, so we're getting down to the end here. Say it for the fourth time, I think, more code means more bugs. All programs have bugs. The only perfect program is one that hasn't been coded yet. It won't work if it hasn't been tested. Test tasks, not tools. Users shouldn't have to read the user manual if there is one, but if there is one and they read it, they'll know more than 99% of all the users. No programming task is ever 90% done. I'm not sure about that one, but it's a good thing to keep in mind. And given enough money, you can turn any program into any other program. So when considering replacing a product with an all-new version, it's often easier to correct the flaws of what you already have than it is to take on a new set of issues that you have yet to discover because you're writing everything again from scratch. I've tried it both ways, and in my experience, if something works okay and you want it to work better, it's way easier to make it work better than it is to throw it away and start over. And again, all user errors should be at least considered as caused by design flaws. I'm going to shut down at this point. We're going to do a full course on this. If you're interested in going into depth on all this stuff, here's a link to our website, to my website, to register your interest in such a course. I will send you guys a note, if I can figure out how to do it.
I'll do that, Alan.
All right, go ahead with the link so you won't have to, God forbid, you have to use a piece of paper. Okay, excuse me. Okay, so let me shut this down. So Ron, I love your picture. I keep looking at it and it says, oh, must be doing okay. He's smiling. Anyway, you have to unmute yourself.
It did let me eat lunch. I'm still only eating lunch.
Okay, well, good. Anyway, so anybody have any questions or comments?
So Jared Spool, who is one of the gurus of user interface design, recently proposed that all of product report to a chief experience officer.
Yeah. Well, I have no problem with that, except that, I mean, that's what Jobs did at Apple.
Yes,
Except he didn't do a very good job of it.
I think he did a hell of a job of it.
Well,
The recent Apples were not created by Steve Jobs.
I know, but that delete thing that I showed you, that's not new. That's always been that way. So, you know, he in my opinion, he did a good job. Don't get me wrong. Apple was way better. There were many fewer ways to do things, which I like, which means less code, fewer bugs. But, you know, Apple wasn't perfect. And if somebody had...
Apple was not perfect, but half those applications you named did not exist in Steve's time. They were not that inconsistency. There were inconsistencies.
Yeah. Well, I mean,
way fewer than anywhere else.
I agree with that. The one thing I would say is, you know, Jobs didn't do user interfaces full time. Number one. Number two, he wasn't trained as a human factors guy, so he didn't have that background. So what I'm looking for is somebody that does it full time, that's trained on human factors and actually has help doing it. But I agree with the idea that one person should be the guru of user interface design. It's the only way to ensure that kind of consistency. And I'm not looking for that job, by the way. It's much easier to criticize. But the fact is, every time I use any of this stuff, and I'm talking to you on a relatively new MacBook Pro, I find bugs every time I use this system. Something hangs up.
Doesn't have anywhere near the quality it had 20 years ago. 25 years ago.
Yeah. I can't speak to 25, but to 2022 I can.
I worked at Apple 25 years ago.
Okay. Okay, good. Yeah, I mean, they did a lot. I wouldn't trade, one of the reasons I continue to use Apple is so I don't have to answer people's questions about Windows.
Yeah, I think,
Me too.
yeah, and I think what you're saying is self-evident today. And in the old days when I was younger, the amount of code we produced and the amount of systems we produced and the architecture was more simple. Nowadays, it's much more complicated, right? And we have tons of code and APIs and so forth.
I don't buy that for a second. And the reason I don't is most of this stuff runs on operating systems that were designed 40 years ago and haven't changed. So the underlying code, the internet stuff, it's been around forever.
Right, I agree with you, but unfortunately, what I'm finding out now when I work with software engineers a lot, when we design our solutions and our architecture now, if I compared what we did 25 years ago, it's much more complicated.
Yeah, there's more function for sure.
Exactly, much more code, right?
Well, yeah, that I'm not so sure is necessary.
Yeah, well, that's the point. The point is, how can we simplify? Back during the XP days, that simple design was part of our engineering, right?
Yeah. Well, I mean, do what Ron's quote, he quoted, I forget who he quoted, but have one guru for user interface design, and have one component for interface design, and have it done in a consistent way for everything. So now you got everything under one roof. And the same thing for the database, and the same thing maybe for the communication protocols, and the same thing, for error recovery.
Yes, you're correct. And that's what we're trying to do now. We're trying to create what we call product teams or feature teams, where we have cross-functional teams where everybody is on the team to do the work, right? I don't have to have 15 dependencies across 15 different teams to do the API to the database. I have somebody on the team that can do it, right? And get it done. Right. But unfortunately, what I'm finding out, and I don't know if you found this out, over time, what we've done at most companies is we've complicated the organizational structure, which maps to our complicated architecture and software solutions, and including our SCM and CIs now, where it's slowly becoming unimaginable. And then wake up, here comes ChatGPT. Here, not just ChatGPT, but now the future of AI. So I have people now who are using this AI and everything to generate complicated algorithms and code.
Well, yeah, but yes.
I know, it's a new world, isn't it?
Again, if you separated things into components, at least you'd isolate all that stuff into one place.
Right.
Or two places.
Exactly. But it'd be nice if I had one team that did all the work in a company that's very large, an organization that, thousands of people, and the IT organization, versus having 1,500 component teams. And I have to all work with, 14 different teams to get the work done.
No, but there aren't 1,500 components. Come on.
Well, surprise. I mean, two companies I've worked at, Yeah, there is, believe it or not.
Well,
It's
okay.
crazy.
So I guarantee you,
It's crazy. It shouldn't be. You are absolutely correct, but that's what it's grown up to.
well, the
What we have happening now is that
the operating system, I'll give you an example. The operating system for that we started with back in the day had 5,000 modules.
Yeah,
Okay, so and a module was the kind of thing an individual engineer could do.
Right.
Could work on.
right.
And so we divided those 5,000 modules, and I was in the room when it happened, into 10 components.
Yeah,
Done. And
Yeah.
we took this component and said, okay, San Jose, that's yours.
yeah, I remember those.
And we went to Kingston, you have this, and blah, 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 blah. And the interfaces were defined and they were managed centrally in Poughkeepsie. And that was the end of that. If somebody had told me, no, don't do 10, do 8, we could have done 8.
I know.
mean, it's like I don't know if you've ever read Latin, but the Julius Caesar thing from the beginning that you do in Latin 101, all Gaul is divided into 3 parts.
Yeah,
Yeah, well, who said so?
that's right.
And it's
Caesar.
like, well, I said so about the 10.
Right.
And the point is, I could have said 8,
Right.
or 5 or whatever, but and anybody can do that. I guarantee you could
Right.
go through these, however, 500 components you said, and you
Right.
could figure out how to organize them into 10 components.
Exactly.
So
Exactly.
do it.
Yeah, so that's what we're doing. And it's the same thing if you look at SAP and Salesforce and everything, they have SAP has many, many modules now, and you have specialization each one of them. And to simplify it so that it doesn't become overbearing to make any change in any installation and customization. That's what people need to focus on, I think.
Well, yeah, you put interfaces in, you keep them constant, and now
Yeah.
you can have independent releases of
Exactly.
components.
Exactly. Any questions? I'm sorry, I kind of took over.
Yeah, no,
So Alfonso had a question.
Go ahead.
Or a comment.
Yeah.
okay,
I don't know if the mic is
I hear you.
functioning better now. Thank you. The problem is it's a lot more complicated than it was 20 years ago or I guess in the 90s, 30 years ago, because now applications are running through the network and typically on a browser and not just directly on a desktop application. And so the building these web applications, there are different languages that are running on the server and on the client in the browser.
I
And there are
understand.
different components in different languages: PHP, Perl, Ruby, and Ruby on Rails, all these libraries. And so part of the problem is a lot of these are built on open source components that have dependencies that the libraries use that the authors of the apps, the web apps, are not familiar with. So and there are problems because of those dependencies. There can be security issues, or they become outdated, and there are conflicts between different components as they start aging.
Sure.
I think, and although I have 20 years of Mac OS development experience and Unix before that, I started using in the past couple of years React Native, which is using web technologies, the tech stack on top of the desktop app. So that's like 3 layers above the user interface and above the OS.
Right.
And that's part of the problem, is that we developers they're making like a Tower of Babel or a Jenga tower.
Yeah, Jenga tower
And
is more like it.
it's it quite often and regularly collapses, and that we have to rebuild. And working with our tools to build these things is frustrating, because working with JavaScript, which is not does not have static typing, but you try to do static type checking with some tools that I've started plugging them in, and it takes 3 or 4 days just to get that working, so that you can get better results. So our productivity is being killed, and that makes it harder for us to ensure that the quality
Sure.
is at a level that we expect from our generation. So now you're one generation ahead of me. My generation, I grew up learning to code in the 70s and 80s, when structured programming was still taught and enforced, and object-oriented programming was coming into the fore. And people these days don't truly understand object-oriented programming, and they ridicule it, and then they misuse the languages that have the functionality. So it's like they're creating the spaghetti code that we tried to get away from in the early 70s.
Yep. I agree with you, and to some extent, the issue is there are people writing code that haven't been properly educated. The 18-year-olds that think they know how to code, to pick an extreme, and they really don't know what they're doing. The other thing is what you talk about is tool selection. I mean, people use tools that they shouldn't be using, from what you're telling me and from what I've heard. The other one thing I take issue with is the complexity. I mean, we've certainly the application development tools that stack one on the other is something new. I don't know that if I was running a software group, I don't know if I'd let people do that, but be that as it may. But the fact is, the distribution of data across the network, the distribution of logic in an application across the network, the distribution of user interface functions across the network is not new. I mean, we did that, not as much as people do it today, but we did it, 30 years ago too.
Yeah, but I think also the mentality's changed. Because what's happening when I talk to a lot of senior leaders in software engineering and everything, code is dispensable. Data is important, but they don't expect code to stay 4 or 5 years. It has to be replaced. Code is what's the word? It's not immutable anymore.
Yeah, well,
yeah. So to them, it's like whatever you write today is going to be replaced. So Google, deploys millions of lines of code a day, and it replaces code all the time, right? So code is not important anymore. It's not valuable. That's what I'm hearing. People.
Yeah, I hear people saying that too. But I mean, look, my daughter is a director level manager in a startup doing software.
Mm-hmm.
And what you're talking about is not their philosophy.
Oh, good.
They're looking to write code that lasts.
Oh, good.
Because it costs money.
Right.
And it ought to have a return. There ought to be you ought to get something for your dollars. And that was the whole idea behind this presentation was you can write software that actually lasts,
Right.
that you can build on, that you can make money off of forever. I mean, the mainframe operating system today and Unix today, and I don't know about Windows or about I don't know much about Apple's software internals, but at least Unix and the mainframe operating system, there's code in those systems that goes back to the 70s.
Yeah, I know, and I'm surprised to see some of my code still running too. But I see that COBOL and Fortran and so forth, I see less and less of that code
Oh,
running.
yeah. Well,
Yeah.
and
And assembler.
well, it's like they're not as sexy as some of the new stuff. But the
Yeah.
point is, okay, they're going to get me started on engineering. I mean, I was trained as an electrical engineer. Part of what I was indoctrinated into during that training was a concept called elegance, solving problems in the simplest, cheapest, least complex way.
Mhm.
And my daughter, who's a software engineer, was trained as an electrical engineer. She thinks the same way. I have a niece that's a PhD student at MIT in mechanical, same thing. Software engineers don't think that way.
Oh, yeah, that's terrible. They should.
Some of
Yeah.
them do. Some
Huh?
of them do.
Some of them do, yeah, some of us do. I'll put myself into that category. But
All right.
the fact is, a lot of them don't have that kind of education,
Right,
don't have that discipline.
right.
And I think, Alfonso, I think part of what you're saying to me is a reflection of that kind of lack of discipline.
Absolutely. Absolutely. But part of the problem, I think, is that because software development started with electrical engineers, it was secondary to their primary function, which was
Oh.
designing the hardware.
Yes,
So they had that discipline.
well,
So when the programmers, when it became less engineering and just get this ship the code, we're more interested in shipping features out than building a system that
right,
that we're investing in, that we want to uh, maintain and use as an asset for as long as possible and build an
yeah,
organization on. Uh, management is looking for promotion to go higher and then outside the company somewhere else. So they're really not there to stick around to see that that software is going to
no,
be
you're right.
as endurable as an engineer will, because if hardware fails, finance guys can quantify it. And when software fails, they don't have finance guys quantifying it, and managers aren't sticking around to pay the price.
I beg to differ. So in 1971, the Fuji Bank in Japan was down for an entire day because the IBM software failed. And there was hell to pay. I mean, the president of IBM Japan had to go to the prime minister of the country and apologize formally. And the word comes down from headquarters, this shall never happen again. And that was the beginning of the 1 year mean time to failure conversation we had during the presentation. That's where all that came from. You can't, I mean, anybody remember IMS? Information management system. It was IBM's transaction process, one of IBM's transaction processing database middleware product. that was that failed, and I wound up going out to California to work with those guys to get whatever the problem was fixed. I mean, that doesn't happen anymore with the mainframe stuff, and it happens all the time with the crap that people run. Remember the big crashes when the Affordable Care Act stuff came online, and I mean, every time all these things get overloaded like crazy and can't take it. Anyway.
Well, these failures, there's a financial cost for the failures, but the organization paying the price of the investment in their software, where they maintain it and don't throw it away every 5 years, like you said earlier,
Yeah,
is a different subject.
Well,
The crashes of the 737 Max and the two
that's a good.
2 week period downtime with, or not 2 weeks, but twice that Southwest Airlines had days of non-operation because their systems were down and
Yeah.
flights were delayed and canceled, or were all strictly software because their management is not doing a good job managing the quality and the condition of their code.
No, I agree with you, and I, and that hopefully someday people will wake up and say we can't do that anymore, particularly on an airliner. Or look at this. Look at cars. The average car today, I'm told, has 125 million lines of code in it. Okay, 125 million lines of code. I'll bet you a lot of money there's at least one bug per 1,000 lines of code, at least. And that, I mean, that's pretty high quality. So if that's the case, there's 12,000, I can't do the math in my head. There's thousands of bugs in the average car. I wouldn't let software drive my car on a bet because of that. I mean, it's crazy. I mean, and people don't take the time. And the only way to get to bug-free code or a reliable code is to keep improving it, not throwing it away and starting over again with a whole new set of bugs.
Well, that's what I was talking about before. That's the cultural change we've gone through right now. So these wealthy people, these executives and companies are not rewarded for that. They're rewarded for replacing stuff, getting it out the floor, and they get millions and millions and millions of dollars, while the average software engineer gets, $100,000.
Yeah.
Elon Musk thinks it's perfectly okay for his car to be beta tested by customers.
I understand. I think it'll,
Your comment about let's not use beta testing.
Exactly.
well, it's true. I mean, you're playing with fire. Look, I was a senior vice president at EMC, and I was a vice president at IBM. I know how those guys think.
Mm-hmm.
They all look at the quarterly goals. And a friend of mine was a Harvard Business School professor, Michael Jensen, wrote a book called Paying People to Lie, or an article. And what it was about was how people lie about and manipulate the quarterly goals. So if you're going to miss your quarterly goals, move business to the next quarter so you're sure to make the next quarter's goals, that kind of stuff. And that isn't going to work for very much longer.
I hope so.
Well, the Supermax's crashing, came close to causing a change. A couple more issues like that, and they're bound to happen.
I hope so.
The more code people write, the more problems there will be.
I hope so.
Until they wake up.
I'm going to call time. It's 10:41 Eastern.
Yes.
So I want to thank everyone. And this is a very exciting, thank you, Alan. And of course, you know, I like this sort of stuff, so I'm a super nerd, so this is fun for me. This is been recorded, so we're gonna release it and let everyone know. So,
Okay.
so Alan, Robert, when, you know, send me the link to where you want people to go for the sessions and everything, and we'll also publicize that in our LinkedIn stuff and marketing.
Yeah, it's on the chat.
Yeah, but we do post marketing too and everything.
Okay.
Yeah, so we'll get the word out, right? So again, thank you very much for
It was a pleasure.
joining us. It was very educational and informative, and I like you. You're an IBMer.
I survived 30 years there.
And so thank you very much, and thank you everyone for joining.
Yes.
Next month, we're going to have Aaron Koppel. He's going to talk about Agile and more about the CAL Certified Agile Leadership training and so forth, because he does a lot of that as well. So stay tuned for that. So thank you, everyone.
Yeah.
See you another day.
Okay. Arrivederci.
Bye-bye.